All right, let's jump right into this explainer. Today, we're looking at the energetic paradigm, or EP for short, and exactly how it proves genuine commercial and operational traction. And we're not talking about catchy marketing slogans here. We're talking about a rigorous deductive proof chain. For any new framework or startup, investors typically look at four key traction tests: demand, execution, scalability, and momentum. But as the source material makes absolutely clear, these aren't just abstract buzzwords. They are brutal tests of whether a method can actually survive real-world pressure. So we're going to explore why EP has this traction, especially as complex AI work increasingly fails. And spoiler alert, it's not failing at generating text, it's failing at deductive reliability.
Here's our roadmap for today. First, we'll hit the AI control gap. Second, execution under pressure. Third, the deductive reasoning engine. Fourth, scalable logic. Fifth, the momentum flywheel. And finally, number 6, the proof chain. Let's get to it.
Starting off with Section 1, the AI control gap. We really have to start right at the root of the problem and ask ourselves, why does advanced AI fail at complex work? As these models get more powerful and, frankly, more confident, the bottleneck is no longer generation. It's controlled deduction. The source explains this perfectly. A weak AI model fails because it just can't produce enough. But a strong model, it fails in a completely different way. It produces way too much, way too easily, and it just won't stay inside a correct structure. It might answer a question that's kind of nearby instead of the one you actually asked. Or it might swap out a critical required mechanism for a catchy slogan. Or worse, it hands you a highly professional-looking document that completely hides internal contradictions. That's exactly where the demand for EP emerges. Fluent generation simply isn't enough anymore.
It's fascinating to see the stark contrast here. On one side, you have the uncontrolled drift of ordinary AI. On the other, the deductive reliability of EP control. Think about it. Ordinary AI might whip up a very persuasive-sounding business proposal, but EP control, it demands that the proposal actually prove how demand, resources, and execution form a viable working system. If AI is going to act as the backbone for enterprise, finance, or law, loose reasoning is a massive structural risk. So the demand for EP is structural. It's the absolute necessity for a paradigm that can discipline AI output into bounded, testable, and deductively reliable work.
Moving right along to Section 2, execution under structural pressure. So that demand leads us directly into execution. The big question is, can a team repeatedly turn intention into output without the whole method collapsing? While ordinary AI is just out there polishing text, EP consistently preserves structure across totally different formats: proposals, contracts, diagrams, even video workflows. For example, ordinary AI might draft a contract with perfect legal jargon, but EP control steps in and asks if the rights, the cost logic, and the governance actually coexist without breaking the system. It tests internal consistency. Or say ordinary AI summarizes a document to make a video. EP control actually deduces the audience path, the visual anchors, and the underlying logic needed to keep the argument intelligible. Real execution traction means the method doesn't just fall apart when you switch from a written article to a governance analysis. It maintains those boundaries, paths, and proofs across the board. That brings us to Section 3, the deductive reasoning engine.
To really grasp how EP pulls off this kind of execution, we need to look at its hard center and move past just basic analysis. The crucial point here is that EP disciplines reasoning into true deduction. It elevates AI from a glorified chatbot into secure, reliable infrastructure. Look, a lot of systems claim to reason, right? But our source points out that reasoning has become way too broad of a term. Usually, it just means basic explanation or pattern recognition. Deduction is much stricter. It asks, if these boundaries and constraints are true, what actually follows? Ordinary analysis might just list off a bunch of factors, but deductive reasoning derives strict consequences. It tests whether a conclusion is structurally necessary, structurally impossible, or just flat out unproven.
Think about this cascading logic for a second. If AI becomes infrastructure, then loose reasoning is a structural risk, one that churns out hidden contradictions instead of true operational control. EP works by turning a problem into a structure. And if the boundary of that structure is weak, well, drift is totally inevitable. If the mechanism is undefined, the claim is completely unsupported. And if a constraint is ignored, the path is unrealistic. This is exactly what deductive reasoning under structural constraint looks like in practice. It gives enterprises, legal teams, and analysts the power to explicitly challenge the AI's output. They can ask, why did the system reach this conclusion? Or, what premise actually supports it? EP makes those exact questions operational. All right, on to Section 4, scalability through transferable logic. Once we have that deductive engine in place, the next big investor test is scalability. How do you expand without losing that core logic? In the AI world, scalability is often completely misunderstood as just claiming you can solve every single application under the sun. But true scalability is disciplined. The source has this great quote: EP expands not by inflating what it claims, but by preserving how it judges. It simply transfers its deductive control logic to test the structure of any complex system. And the structure it uses is elegantly simple but incredibly powerful. Where's the boundary? What converts input into output? And what feedback stabilizes the system? EP scales across domains because, honestly, complex work repeatedly faces the exact same structural problems: boundary failures, path drift, untested claims. EP doesn't strut in and say, "We have mastered this domain." Instead, it says, "Hey, if this domain involves complex systems, we can test the structure of its claims." That logic transfer? That is true scalability traction. Which leads us to Section 5, Momentum from Capitalized Correction.
Let's explore momentum. This happens when each step actually makes the next step stronger, literally turning errors into assets. Momentum is fundamentally different from just running around being busy. Instead of just fixing a typo locally, EP turns correction into capital. It converts the friction of one output into reusable rules and workflow constraints for the future. Let's look at how this flywheel spins. In ordinary AI work, you correct a mistake on the page, the mistake vanishes, but the system is probably going to make that exact same mistake tomorrow. In EP, a failure is identified and classified. That classification becomes a hard boundary. That boundary then forms a quality gate. And finally, that gate becomes a strict constraint for the next workflow. So if a visual output looks super polished but fails semantically, the deeper rule becomes visual quality must be subordinated to semantic structure. Failure becomes a rule. The rule becomes a boundary. This is exactly how momentum improves execution systematically. And finally, Section 6. The traction proof chain. Now we can assemble all these pieces into one unbreakable causal chain. This proves that these 4 tests are absolutely not just separate marketing slogans. EP's traction derives sequentially from the inherent failures of ordinary AI, all the way to a capitalized momentum flywheel. Let's trace it out. Demand emerges because there's a glaring control and deduction gap in complex AI work. Execution follows because EP provides a structured method to maintain boundaries under pressure. Scalability is achieved because this deductive logic transfers cleanly across domains without any exaggerated ownership claims. And then momentum forms because every single correction becomes a reusable rule that strengthens future deduction. This traction isn't just self-declared, it follows entirely naturally from how the method itself operates. To wrap things up, EP demonstrates incredible traction because it squarely addresses a massive shift in AI work. The true measure of success is no longer about how much a system can produce. It's about how well it can deductively prove its conclusions. This framework explains why traction forms, shows how controlled deduction produces it, and turns repeated correction into a much stronger operating method. So, I'll leave you with this to chew on. As AI takes on increasingly high-stakes work, can your enterprise really afford to rely on mere generation? Keep questioning the structure behind the output. And thanks for joining me for this explainer.